Hi everyone, let us now start talking about our chapter 7, the hypothesis testing. So the first thing is, what is hypothesis testing? It is about making educated guesses about the unknown population parameters. In the last chapter and in the previous chapters, we've talked about how a sample is extracted from the population and then you do statistics on the sample to make inferences to the population. These inferences or this method is the hypothesis testing. One of the methods to make inferences to the population is called hypothesis testing. There are 4 primary questions that must be answered before you start your hypothesis testing. What is the relevant or what are the relevant populations? Because you could have more than one population, and we will see that in the later on chapters. How is the sample extracted from the population? We've talked about this in the sampling chapter 5 about the different types of sample, the probability sampling and the non-probability sampling. What characteristics of the sample, people, animals or object will serve as the target of the measurement, as to what you are measuring, what are your variables, and what is the statistical focus. What are you doing? Are you doing correlation? What is happening? Is all that is included in these 4 questions. Before you start hypothesis testing, you need to have answers, or you should have answers for all these 4 questions. A simple recap about chapter 5 is those 2 words that is called statistics and parameter. The same 4 questions were there in chapter 5 too. If you will look at page number 94 and 95 of your book, again the same question. What is the population? How will be the samples taken? What characteristics will be measured? And what's the statistical focus? How will the samples be taken was the question that was answered by chapter 5. After these 4 questions have been decided, that's when the hypothesis testing is done. The concept of statistics and parameters should be clear, but let's review it one more time. When you have a sample that has been extracted from the population and you do statistics on that, those numerical values are called statistics. However, if you are talking about the values, the statistical focus of the population, then they are called parameter. The parameter, of course, you can never compute because the measurements only exist for a portion of the population. That means you can only do statistics on the sample, and you sometimes do not have the whole population. Most often you do not have the whole population with you. So this is the inference, the process is used as the hypothesis testing. Now, very important to notice on page number 95 is the different symbols used to signify the concept in the population and in the sample. So if you look at the mean has an X bar or a capital M for the statistics, but for the population it is a mu. So those are the things to notice about the variance, standard deviation. Is when you look in an article and you see the various symbols, you could know whether they're talking about the sample or they're talking about the population. So let us come back to the hypothesis testing. Your author from the book gives 6 steps for hypothesis testing about stating the null hypothesis, state the alternate hypothesis, select the level of significance, collect and summarize the sample data, refer to a criteria for evaluating the sample evidence, make a decision to discard or retain the null hypothesis. While he gives the 6 steps, he talks about these steps out of order, and we will do the same thing because it helps understand the process better. So let's look at the first step. stating the null hypothesis. What is null hypothesis? The null hypothesis is a pinpoint statement as to the unknown quantity of the parameter in the population of the interest. So basically what it means is the null hypothesis is you are talking about what would be a pinpoint statement for the population, like the population mean would be 0 or a population mean would be 25. You are making the hypothesis a null hypothesis that this is what you think to be the pinpoint statement. The symbol for null hypothesis is always capital H with a naught. It is said as H naught is the null hypothesis. So the way to write the null hypothesis is you put H naught with a capital H and the 0 as the subscript, which we were talking about is the symbol for the null hypothesis. Then you put a colon, then the parameter symbol that indicates the researcher's statistical focus. Remember that this is the parameter symbol. That means it deals with the population, the equal sign, and then the pinpoint numerical value that the researcher has selected. So like in this case, you have H naught colon mu, which is the mean, equals to 25, because this is what the researcher is saying the null hypothesis is. Or you could have H naught colon mu is equals to 0. Most often, the null hypothesis is set up as a no difference statement, but sometimes that is not the case also. Where does the null hypothesis come from? The null hypothesis basically comes from, just a second, I'm going to go back to my read mode. The null hypothesis comes from the fact that from the statistical focus of the research. So if your statistical focus is about the mean, then you will use mu. But if the statistical focus is about the correlation, then you would use P or something else, as stated on page number 132 of your chapter 7. The notion of H naught is positioned on a continuum of possible values. That means it has the restriction that it must lie somewhere on the continuum. It cannot be fixed for the upper or the lower limit. Look at page number 133, in which you see that H naught colon, you have your variance is equals to negative 15 is not a possibility, because you cannot say that your variance is going to be. And then you have an H naught P is equals to plus 1.3, which is not possible again, because your correlation coefficient has to lie between plus and minus 1. So you cannot have a minus 1, because that is the lower limit, or you cannot have plus 1.3 because that is beyond, that is not in the continuum. You also have the variance has a lower limit of 0, so you cannot have the variance equals to be 0, and if the lower limit is 0, there is no way that the variance could have a value of negative 15. So all the ones that are shown on page number 133, the 4 examples that are shown, tells you why it cannot be. So that is one of those things. The next one is a very important point, is the fact that the researcher sets up the null hypothesis in a way that the research disagrees with it. So you are setting up the null hypothesis in a way that the researcher would say that the results show that the null hypothesis is rejected. And most often that is the case that is happening. Another example is when you are talking about, let's say, two of the populations, males and females, like that is given in your, or boys and girls, that's given in your book, you are setting up your null hypothesis H naught colon as mu1 is equals to mu2, which means you're saying there is no difference in the means attained by the boys population and the girls population.
So you're setting it up in a way of a no difference statement, and then you are hoping to disagree with this statement. It is H naught is like the researcher's hunch. The researchers knows that there should be a difference, so you set up as H naught as a no difference statement to disagree with it. All right, let's look at the next step that is there, which is about the step 6. So we talked about the step 1. Now we're going to talk about the step 6, because we just talked about rejecting the null hypothesis or fail to reject the null hypothesis. Like I said, your researchers generally set up the null hypothesis as a way to disagree with what they actually believe to be the case. It is associated with any given study, is not an articulation of what the researcher believes is going to happen. So whenever the researcher does the calculations and does the inferences and all, they either reject the hypothesis, or if they asserting that the H naught was false, or in the other case they fail to reject the null hypothesis. You never say that you accept the null hypothesis. You say you are failing to reject the null hypothesis. The different ways researcher talks about having rejected or not rejected null hypothesis is seen on page number 135, 136 of your book. Is like null hypothesis was tenable, or H naught was accepted, or no reliable differences were observed, no significant differences were found, the result was not significant. Most often when you are talking about fail to reject null hypothesis, they use that terminology, or they use this terminology to do that. Very, very rarely do you see that the researcher says that null hypothesis is accepted. So those are the few ways that you are going to talk about deciding what to do with the null hypothesis. Now let's look at the next one. So we looked at step 1, which was stating the null hypothesis. We looked at step 6, which was make a decision about the null hypothesis. Now we are looking at step 2, which says you are going to talk about the alternate hypothesis that you set up. The alternate hypothesis is HA, that means capital H with an A as a subscript, or H1. The alternate hypothesis always takes the form of the null hypothesis. For example, if you look over here, your null hypothesis is mean is equals to 25. So your alternate hypothesis says mean is not equals to 25. Here your null hypothesis is saying that mu1 is equals to mu2, which means the mean of one population, let's say boys, and mean of the second population, girls, is equal. Then your null hypothesis is saying that mu1 is not equals to mu2. So it is always stated in the same form as the null hypothesis. Your alternate hypothesis could be directional, which means it could be one-sided, or it could be non-directional, which means it can be two-sided. What does directional means? Well, directional means is you are stating whether your null hypothesis, the mu of men is less than the mu of women, or you state that mu of men is greater than mu of women. The non-directional would be you say that mean of men is not equals to mu of women. So you don't know whether the mean of men is more or mean of women is more. That is called non-directional hypothesis. So think about this way. If we reject the null, that means it is in favor of the alternate hypothesis. So what we were talking about, the researcher using the null hypothesis in a way that they have to disagree with it, and then you choose an alternate hypothesis in a way that researcher really thinks what is going to happen. The directional and the non-directional option leads to one-tailed or two-tailed test, which we will be talking about in a few more in another chapter. Now look at page number 138. If you see on the box that is given, the expert 7.11, you have your null hypothesis. H0 is set as P1 minus P2 equals to 0, which is same as P1 is equals to P2. That means the correlation coefficient for the two populations would be the same. But your alternate hypothesis is P1 minus P2 is not equals to 0, which is a non-directional. It is non-directional hypothesis, alternate hypothesis. So same way, it is mu man not equals to mu woman is a non-directional two-sided hypothesis. I hope you guys are clear about this. So your P1 here in the expert 7.11 is the population proportion of administrators who select a certain outcome, and P2 is the proportion of social workers who also select that outcome. So it's trying to say that the mean of both of them is not equal. So that is a non-directional. If I say which direction it needs to go, either P1 is greater than P2, that becomes directional, and then if P1 is less than P2, that again becomes directional. You have also some non-directional alternate hypothesis shown on page number 139, which shows if your mean is 100, the mu is not equals to 100. If your correlation is plus 0.2, it is not equals to. So basically it takes the same form, but it is non-directional in and the directional is given. So one-tailed, two-tailed test. So we've talked about step 1, we talked about step 6, we talked about step 2 is choosing an alternate hypothesis. So in your research study, you choose a null hypothesis, then you choose an alternate hypothesis. Now we are going to go and talk about step 4. Let me go back and show you guys this slide again. There is a reason that the step 3 is, we are not talking about it. So collect and summarize the sample data is what we are going to talk about now. So in this part, this step is actually called the principal stepping stone. Your book gives an example of the fact that suppose you are driving down a road and you come to a traffic light. Whether you keep driving or you stop or you slow down depends on the traffic signal that is there. In the same way, you cannot make any decisions without the scientific evidence that is produced by the statistics that you do in a research, which is what is when you state your null hypothesis, you collect your data, you reject the null hypothesis if the data is inconsistent. For example, you have testing IQ. If the difference between the mean of the male is, your null hypothesis says that the mu, that is the mean of males, is equals to the mean of the females for the IQ, and if it is 1/10, then you can think about it as being about some sampling error. But if the difference is 20 points, that strongly suggests that we have a situation where the data is inconsistent with what one would expect if null hypothesis were true. So the concept of sampling error suggests that neither sample mean would turn out to be exactly equal to the population parameter, and hence 20 IQ is quite improbable if the null hypothesis is true, and hence the researcher rejects the null hypothesis. There are two ways of summarizing the sample data of the null hypothesis is, one of the ways is you convert the sample data into a standardized number, which is called a calculated value or the test statistics. We have talked about standardized test statistics, and this test statistics could be T, could be F. There are different kinds of test statistics, which right now you do not need to know the difference between the different test statistics, but this is your calculated value, and then you use that calculated value to make the decision. An example is given in your book on page number 141, the expert 7.14, in which you would see that R has three different values, 0.42, 0.13 and 0.19. So the researcher says that the value of R of 0.42 is so inconsistent with the null hypothesis that the sampling error alone cannot be considered to be an inadequate explanation for why the observed correlation is so far away from the pinpoint number in the null hypothesis. So obviously we expect some discrepancy between the 0 and the database value of R, but this is a very big difference, and hence the null hypothesis is rejected. So the second way of doing the collection and analysis of sample data is the researcher use a computer to perform the data analysis. They either use a built-in hypothesis, the null hypothesis, or tell the computer what the null hypothesis is, but the researchers specify what the alternate hypothesis is, directional or non-directional, and once the computer knows both the null hypothesis and the alternate hypothesis, it analyzes the sample data and computes the probability of having a data set that can deviate as much from the null hypothesis as the data set is being analyzed. So the computer informs the researcher the probability by which this could take, the P of it, and then it fills it up with a single decimal value between 0 and 1. This is the value that the researcher uses to reject or fail to reject the null hypothesis. So remember what we have just talked about. We have talked about stating the null hypothesis, stating the alternate hypothesis. We have talked about our final decision, step 6. We talked about collection and analysis of sample data. So now we are going to talk about the step 5, the criteria for evaluating the sample evidence. You have to remember these two ways of summarizing the sample data, because these are the two ways that we are going to talk about in our step 5. So the primary question is, are the sample data inconsistent with what would likely occur if the null hypothesis was true? So if your answer is yes, so that means you reject the null hypothesis. But if the answer is no, you fail to reject the null hypothesis, which is your step 6 of the decision. But you might ask is, how does the researcher decide these labels? What should be attached to the sample data? So here is what happens. You ask yourself the question that does the observed difference between the sample evidence and the null hypothesis is a big difference or a small difference? So there are 3 possible outcomes when the numerical summary of the sample data is compared with the null hypothesis pinpoint number. And that leads to your decision about the null hypothesis. If they are identical, obviously null hypothesis cannot be rejected. That means it is true. But if the difference exists, is it a small difference? That means small enough within the limits of the expected sampling errors. and therefore it is not logical to reject the null hypothesis. Or if the difference is there, it is a big difference. That means it is larger than likely to be produced, cannot be produced by the sampling error, and hence null hypothesis should be rejected. This value that we are talking about, how does the researcher decide whether this difference is a small difference or a big difference? This is decided by the calculated value against, so your calculated value from the statistic by comparing it to something that is called the critical value. This is very important. The critical value is nothing more than a number extracted from one of the many statistical tables developed by the mathematicians. Now, you do not have to spend time in locating. How do you locate? How do you find the value on a table? But you need to know about the critical value. So once again, remember we talked about the T and the F. It could be a chi-square or it could be a test of correlation coefficient. And then the decision rule would be to reject the null hypothesis if the calculated value is at least as large as the critical value. Or the second way is to do it with the P, that is the level of significance. The P value takes between the scale of 0 and 1, and so this criteria is called the level of significance. It functions as the critical value, like in the first procedure for evaluating the sample evidence. The decision is the same as the second process, is if the p-value is equal to or smaller than the criteria, then the sample is viewed as being inconsistent with the null hypothesis, and if the p-value is larger than the criteria, then the data is looked at being consistent with the null hypothesis. So you are looking at two things. You are looking at either the critical value, I'll repeat again, the critical value, which is again comparing the calculated value that is obtained in step 4 against the tabled critical value, or you compare the database p-value against the level of significance. It is the same thing that we talked about in step 4, is the two process of doing the thing. One was a calculated value, that is the T or the F or the chi-square, and then it was the p-value. I'm not sure why this keeps popping up, and here it is, those two procedures. The researcher cannot himself or herself decide what it means to be a small or a large difference. They have to have some criteria, and this criteria are either the critical value or the level of significance. So there are two things. One of the big things to note about this is it doesn't matter which process you do. It doesn't matter whether you use the critical value or the level of significance. Both those two procedures will lead to the same decision. If the researcher conducts a F test and rejects the null hypothesis because the calculated value is larger than the critical value, it should be the same thing if the researcher was to compare the database p-value against the level of significance and show that it is smaller than the level of significance. So it is the opposite. The calculated value is larger than the critical value, then it is the null hypothesis is rejected. But if the p-value is smaller than the level of significance, then the null hypothesis is rejected. So this is the same whether you do the critical value or you do the level of significance. Let us now go to the part is about level of significance. The level of significance is the scientific cutoff point for deciding whether the null hypothesis should be rejected. This is an important point and a very critical point, is the scientific cutoff point for deciding whether the null hypothesis should be rejected. The most popular levels of significance are 0.05 and 0.01. Sometimes you also have 0.001, but 0.05 is the most commonly used level of significance, p-value. As I said, that the level of significance is very important because it actually forces the researcher to become involved in determining how rigorous the criteria should be. So suppose I have a 0.05, but I actually set up the criteria as 0.01. That means I want it to be more rigorous in rejecting the null hypothesis. This is something, the step 3 of selecting the level of significance is something that the researcher must do prior to collecting the data that has an impact on how large or small the criteria number should be. So before the data is collected, the researcher must select the level of significance. Now, the level of significance obviously influences the size of the critical value. Like I said, both those procedures, whichever one you do, will yield the same result. The level of significance is sometimes not, the researcher sometimes doesn't use the words level of significance. Sometimes researchers use what is called the alpha. So they would use the alpha level that is set to 0.05, assert p is equals to 0.05 or p is less than 0.05. They are the different ways that these researchers state the level of significance. But H0 or null hypothesis will be rejected if p is less than 0.05. Sometimes, as I said, the levels of could be 0.01. Now, one of the most important things to talk about is the type 1 and the type 2 errors. So what, like we talked about, is that you either reject the null hypothesis or you fail to reject the null hypothesis. So there could be, you never prove that null hypothesis is true or false by the means of hypothesis testing. It is about rejecting or fail to reject. Now let's look at type 1 and type 2 errors. The type 1 error is the mistake of rejecting the null hypothesis when the null hypothesis is actually true. So suppose you set your significance level to be very high. Instead of even setting it 0.05, I set it up as 0.1 and I reject my null hypothesis even though it was not correct. So I mistake of rejecting the null hypothesis when it was actually true. So that is called the type 1 error. So automatically you would think that, okay, so the best way to avoid type 1 error is for me to choose the level of significance to be as rigorous as possible. So why not choose 0.001? Because I will never end up making type 1 error. I would never reject a null hypothesis in case it is true. But then this leads to what is called the type 2 error, is when you make a mistake that the null hypothesis is not rejected when the null hypothesis is actually false. So there is where the balance between type 1 and type 2 errors occur, because type 1 error means that you are rejecting the null hypothesis when it is true. But type 2 error is when you do not reject the null hypothesis and it is actually false. So if you choose your level of significance to be like 0.001 in some cases, now some researchers do choose that, but if you choose it to be too rigorous, like 0.00001, you come into type 2 errors is because you would not reject the null hypothesis when it is actually true. So this is where the balance that the researcher has to do in what should be the level of significance. The type 1 error is more dangerous than the type 2 error. So that is very important to note. So The reason is the fact that you do not want to do not reject the null hypothesis when it is actually true. So this is why studies which actually take the critical level of 0.2 are not considered too good, because they are too lenient in their level of significance. Most common experts use 0.05 as the alpha level. This is about type 1 and type 2 errors. Now let us look at the 2 points of possible confusion regarding the levels of significance. This is given in page number 151. So the first confusion is, does the alpha level somehow determine the likelihood of a type 2 error? No, that is not the case. The alpha level does not influence type 2 errors. I understand the way you are thinking about it is because if I set it to be more lenient, then there is chance of it affects the type 1 and the type 2 errors. But no, it does not determine the type 2 errors, because if I make it very low, I am not rejecting the null when the null hypothesis is really true. This effect, the type 2 error, is actually other features such as the sample size, population variability, and the reliability of the measuring instrument used to collect the data result in the type 2 likelihood of type 2 error. The second point of confusion is that if null hypothesis is rejected, does the alpha level indicate the probability that the null hypothesis is true? No, that is not the case again. If the researcher ends up rejecting the null hypothesis after having a set of level of significance, let's say as 0.05, you cannot conclude that the chances of null hypothesis being true is less than 5 out of 100. That is not the case. This is actually, if the alpha is set, that means the level of significance at 0.05, then the chances that 5 out of 100, the null hypothesis is rejected if the null hypothesis is actually true. That is what the level of significance is saying, is that 5 out of 100 chances the null hypothesis is rejected if the null hypothesis was to be true. So this is important for you all to understand the level of significance. In your assignment, you have an article that talks about identify the null hypothesis, identify the alternate hypothesis, identify the level of significance. You really just have to look at what is the null hypothesis stated, what is the alternate hypothesis stated, what is the level of significance. Now let us look at the results that are highly significant or are the near misses. In very real sense, the level of significance plays like a dividing line. The P determines that causes a result to be highly significant. Statistical significance is positioned on one side of the line, and the lack of statistical significance is on the other side of the line. So the P gives you the dividing line. So sometimes researchers do not like to summarize their result by just reporting the null hypothesis was rejected or was not rejected. They like to show the readers how much is the discrepancy between the database p-value and the level of significance. So if you look on page number 152 and 153, is they actually show you what is the it went down. P is less than 0.00001, which is a very rigorous criteria. And the same thing in 7.27 is even further rigorous than that. So one of the ways they do this, researchers, is first they will set their p-value to be 0.05 and they would test it with 0.05. Next, they check if the sample data would have been significant as 0.01 level, if 0.01 level would have been selected as the alpha. If the answer is yes, then they check again to see if the data was significant at 0.001 level. This process continues either 1. The data cannot beat a more rigorous level of significance. That means it stops at, let's say, 0.0001. Or the researcher does not want to check further to see if the P might beat an even impressive value of alpha, which is the level of significance. So experts 7.26 and 7.27, that is what the researchers have done. Some researchers do this, while some other researchers would test more than one null hypothesis in the same study, and they would choose their P to be less than 0.05. So you have 4 different P statements as less than 0.05, less than 0.01, less than 0.005, less than 0.001. They're all connected to the results. So that is another way about talking about the different P levels in the same study, even though a constant alpha is used as 0.01. Now let us talk about the near misses. On page number 154 of your book in excerpt 7.28, your p-value is 0.051, which is very near to be rejected, but it is not. So in this case, the p-value fails to beat the alpha by a very small amount. So the researchers often say, instead of failing to reject the null, they would say is they've achieved marginal significance, or their findings have approached significance, or there is a trend towards significance, or results borderline significance. So there are 4 alternative labels for an outcome that is a near miss. That is a marginal significance, approach significance, trend towards significance, or the results indicate borderline significance. So that is one of the things seen in 7.28. But some researchers believe that near misses are just miss. They choose a level of significance at the beginning of the study and then never change it. They will summarize that P lies on one side or the other side of alpha. So in this, they will reject and they will say was not statistically different, even if P is 0.051. So there are 2 ways that they approach the value. Some researchers may give the 4 different levels, or they would do an all or nothing approach to hypothesis testing. So the last thing that we want to talk about is the few cautions that your book mentions. So the first caution is about the 2 meanings of alpha. The alpha in hypothesis testing designates the level of significance selected by the researcher. But when you are discussing the measuring instrument, alpha means something else. It actually refers to the estimated internal consistency of the data from the questionnaire, inventory, or the test being discussed. So those are the 2 different meanings of alpha that you need to be aware of. The second about is the importance of null hypothesis, H0. When you are talking about H0, some researchers do not take the time or space to publicly indicate the precise nature of H0. They presume that the readers will understand what the null hypothesis is. And even the fact that they do not talk about rejecting or failing to reject the H0 in the abstract. Your final decision related to hypothesis testing procedure is always has reference to the point of departure. That means they always terminate the hypothesis testing procedure by rejecting or failing to reject a specific null hypothesis. Another caution is the ambiguity of the word hypothesis. When we are talking about the word hypothesis, it is talked about like a hunch. So research hypothesis. If you look at page number 157, the excerpt 7.31, you see H2A was rejected while H2B was accepted. So at a quick glance, you would think one of them is the null hypothesis, but that is not the case. They both are actually research hypotheses that the researcher has made. So if you are confused about the word hypothesis, search around the article and you will find out as to what are the alternate hypotheses the researcher has made. Sometimes when the next caution is when the P is reported to be equal to or less than 0, that is misleading. For it does not mean that an imaginary population defined by H0 has no chance whatsoever. This generally happens when there are computer generated P and the P value is very small. The computer would give out a P value of less than 0. So you have to be careful about those situations. The last caution is about the meaning of the term significant. When you talk about significant in a real life, it means something different than the usual important, noteworthy, big. But the word significant is different in hypothesis testing. It does not necessarily mean that the results are important or that the absolute difference between the sample data and null hypothesis is found or it is very large. It just says that there is a statistical difference. That means it is simply that the finding cannot likely to have happened if the H0 is true. That means if null hypothesis is true. As long as the sample data is inconsistent with what you would expect from a true null hypothesis, the statistical claim can be made that the results are significant. The quality of the research question that provides the focus for the empirical investigation and the quality of the research design that guides the collection of data are the one that are most important results, are what influences the important results. Here it just talks about that yes, it is significant, for in the sense is that it could not have occurred if the null hypothesis was true. This concludes the chapter 7 of hypothesis testing.